Good day everyone! Welcome to Sir Fox Learning Channel once again. For today's video, ang pag-aaralan po natin ay patungkol po sa fluid mechanics at specifically Bernoulli's principles. Ito po ay under pa rin po sa MELC number 29, week 6. What? Week 6. Kaya off ka muna ngayon si Sir Fox. Nahihiya sa sobrang late na nito. Okay? Our learning target for this video is to apply Bernoulli's principles and continuity equation whenever appropriate to infer relations involving pressure, elevation, speed, and flux. Pag sinabi po nating Bernoulli's principles, it states that an increase in the speed of a fluid occurs simultaneously with a decrease in the pressure or a decrease in the fluid's potential energy. And these principles, of course, was named after Daniel Bernoulli's, a Swiss mathematician. Alright, Bernoulli's principles explains the relationship of pressure, volume, and height or elevation. So this is our elevation or height. Of course, the volume of the fluid flowing here and the pressure of the fluid flowing on the pipe. So let's consider the pipe. And Bernoulli's principles expressed as P plus rho over 2 times V squared plus rho times G times H, which is constant. And this equation is composed of 3 terms. And these terms are actually pressures, represent a pressure. The first one is the static pressure. And this is a dynamic pressure, which represents the kinetic energy in the system, plus this pressure is the hydrostatic, which represents the potential energy. Here you have, for static, P is pressure. For dynamic pressure, which represents the kinetic energy, rho over 2, this V is the velocity of the fluid. And for hydrostatic, this is the density of the fluid times acceleration due to gravity and the height. So dito po makikita po natin na the principles states the relationships between the pressure of the fluid, the volume of the fluid, and the height. That's why meron po tayong acceleration due to gravity na G, which is constant in Earth na 9.8 meters per second squared. This expression is actually in terms of pressure. So you have here fluid pressure. P is the fluid pressure represents as the first term as the fluid pressure that flows out here, and the second term represents as the velocity of the fluid that flows here, and the last term represents the gravitational acceleration of the fluid as the height changes. Bernoulli's principles can also be expressed in terms of energy and head form. So in terms of energy, we have here pressure over the density of the fluid plus the velocity, the square of the velocity of the fluid over 2 plus acceleration due to gravity times the height. And in terms of pressure, which I discussed a while ago, P, or the pressure plus the density over 2 times the square of the velocity plus rho, or the density of the fluid times acceleration due to gravity of the fluid times the height of the system. And in a head form, pressure over the density times acceleration due to gravity plus the square velocity over 2g plus the height. And these are all actually constant, which represents or signify that there is a conservation of energy. In terms of pressure, Bernoulli's principles, which is equal to P, yan, plus the density over 2 times V squared plus rho times G times H. So sometimes is expressed as, so this will be your initial pressure, initial velocity, kinetic energy, and this is also your initial potential energy, equal to P sub 2 plus your final kinetic energy plus your final potential energy, density times acceleration due to gravity times height. Okay? And by canceling the potential energy here, you will now have P sub 1 minus P sub 2 is equal to rho over 2 times V squared sub 2 minus V squared sub 1. As your Bernoulli's principles equation. Alright, for our example and exercises, we have two problems here, problem number 1 and problem number 2, and probably bigay ko na lang sa inyo yung problem number 2. Okay lang ba? So for problem number 1, we have here a perfume in a bottle has a density of 920 kilograms per cubic meter and its level is 0.25 meters below the nozzle. Calculate the minimum speed of the air so that the liquid will reach the nozzle. So kung ito po yung perfume natin, nozzle daw. So ito yung laman. And then, ang height daw nito na walang laman ay 0.25 meters. Kasi malaking bote ito kasi 0.25 meters eh. 25 meters. Yan yung height ng walang laman. And then, yung density ng perfume na to, yung density niya ay 920 kilograms per cubic meter. 920 kilograms per cubic meter. Yan yung density ng perfume. And then, ang density ng air. So, ito may laman, ito wala. So, ang probably, air ang laman yan. Diba? Sa isang container, kapag walang laman, probably, hangin yung laman yan. So, ang density ng air dito is equal to 129 kilograms per cubic meter. Ano yung initial velocity? Kung merong pump, di ba? Usually merong pump yan eh. Ayan, pump yan. Ano yung initial velocity na pwedeng i-pump dito? Ayan, para lumabas yung perfume. So, sa given po natin, ayan, nandiyan na rin sa ating illustration, our height is equal to 0.25 meters. Okay. And then, ano pa yung given natin? Velocity, final velocity, probably 0 kasi nga, walang way out eh. Wala siyang way out. Di ba sa Bernoulli'S principle, dapat may way out. Dito, ang way out, pabalik. Kaya, probably, ang final velocity po natin dito is equal to 0. And then, of course, may given po tayong density of perfume, which is equal to 920 kilograms per cubic meter. Density of air, which is equal to, area na, 1.29 kilograms, hindi na nakikita, per cubic meter. Okay? So, ang hinahanap, initial velocity. So, dito po tayo. Ang ating Bernoulli's equation, so, lagyan po natin ng separating ano. Ang ating Bernoulli's equation is P sub 1 is equal to rho over 2 V sub 1 squared plus, ayan, kikita na, pakita natin, plus density times acceleration due to gravity times height. So, this is initial, which is equal to P sub 2, hindi pala equals plus yan, plus over 2 times B sub 2 squared plus density, acceleration due to gravity times height, 2. Now, in this equation, sa equation na to, ang makikita po kasi natin, since base nga dito sa ating illustration, walang way out, ito, saka ito, is equal to 0. At ang ating velocity dito ay equal to 0 din. So, ang natira na lang, P sub 1 plus, ayan, rho over 2 V squared sub 1 is equal to P sub 2. Yan na lang natira. Oh. And then, since yan na lang po ang natira, pwede po nating ilipat to dito. Kaya magiging negative P yan. So, mangyayari magiging rho over 2 V squared sub 1 is equals to P sub 2 minus P sub 1. Okay? Ang hinahanap po natin ay ito. initial velocity, di ba? Ito yung hinahanap natin. So, para mailabas natin to, ang gagawin lang natin is to multiply muna by 2. Both sides. Multiply by 2. Multiply by 2 para ma-cancel out yan. So, mayroon na kayong rho v sub 1 squared para mailabas natin to, di ba? Is equals to 2 times p sub 2 minus p sub 1. Okay? And then, para mailabas natin itong v sub 1, saka na tayo, ngayon na tayo magdi-divide ng rho. Yan. So, over rho. So, meron ka ng v sub 1 squared is equal to 2 times p sub 2 minus p sub 1 over rho or density. Para maalis natin itong 2 dito, ang gagawin lang natin is square root natin yung both sides. Square root niyan para ma-cancel out. So you have now v sub 1 is equals to the square root of, pakita natin, 2 times p sub 2 minus p sub 1 over density. Kapag sa gauge pressure kasi, kapag nagbabago yung pressure, kapag nagbabago yung pressure or delta P, that is equal to density times acceleration due gravity times height. So, kapag nagbabago yung pressure, sa gauge pressure yan. So, therefore, kung ito po ay ipapalit natin dito, yan. Diba? Change in pressure yan. P sub 2 minus P sub 1, that is change in pressure. So, pwede nating palitan itong delta P. Okay? Kaya, ang V sub 1 mo ngayon is equal to the square root of 2 times value ng delta P, density, acceleration due to gravity, times height. Ganyan natin. All over yung density ng air. So, ito density ng perfume, ito density ng air. Acceleration due to gravity na constant, ito height ng space na walang perfume. Okay? So, substitute na tayo ngayon. By substitution, V sub 1 is equal to the square root of 2 times 920. Ang given natin, 920 kilograms per cubic meter times 9.8 meters per second squared times 0.25 meters. 0.25 meters. So, i-multiply mo ito dito. Pwede ring multiply mo muna lahat to times 2. Parehas lang naman yung kakalabasan. All over 1.29, the density of air, kilogram per cubic meter. So, your V sub 1, saan na ba? Yan, nakikita pa. Your V sub 1 is equals to the square root of, pag minultiply po natin to, 920 times 9.8 times 0.25, that is, bring down to times 2,254. 2,254. Sulat mo lang muna yung mga unit measure. Kilogram per cubic meter dot meters per second squared dot meter. Ayan. All over 1.29 kilograms. Nakikita pa ba? Per cubic meter. Pwede na natin i-cancel out to. I mean, ito tong unit lang, hindi to itong unit. So, that is equal now to, masikip na ang mundo, the square root of, pag minultiply po natin itong 2 times 2,254, ang kakalabasan po niyan ay equivalent sa 4,508. 4,508. So, ang matitirang unit, meters per second squared times m is meters squared per second squared. Divide 1.29. Ang kakalabasan po niyan ay 3,494. Square root of 3,494.58 meter squared per second squared. At ang square root po niyan is equal to 59.11 meters per second squared. This is your V sub 1. Ito yung velocity na kailangan para yung perfume umabot sa nozzle.